Good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening, children. Good evening.
Good night, ma'am.
Good evening. Sorry, children, I'm 15 minutes late in starting the meeting. Meaning I started, but I was not able to get started with the class. Sorry. Let children So I'd ask you to work question number 1, 2, and 3, right?
Yes, ma'am.
Yeah, question numbers 1, 2, and 3. Yes. Can I have the answer for the first one?
Ma'am, length is equal to 8 meters, breadth is equal to 12 meters, and height is equal to 16 meters.
Okay, let me first unshare my screen. Okay, so you assume the length, breadth, and the height to be 2x, 3x, and 4x meters. All right. What is the total surface area of the box? What is the total surface area of the box?
Ma'am, 416.
416. What is the total surface?
Square.
52x square.
Yes, ma'am.
52x square. That is Nivedita or Pratiksha?
Satvika, ma'am.
Oh, Satvika. 52x square. Very good. The total surface area of the box is 52x square. Correct, Satvika. What is the cost of covering the box at the rate of rupees 4 per meter square?
Ma'am, 208x square.
Rupees 208x square. What is the cost of covering the box at the rate of rupees 450 per meter square?
234x square, ma'am.
234 rupees to 234x square. Now the difference between these two costs is 416. So the value of x, what is the value of x you got?
4, ma'am.
X is 4 and hence the dimensions are 8, 12 and 16. Good, Shreyas and Satvika. The next one, what is the surface area of the cuboid? What is the surface area of the cuboid?
$240 centimeters square.
240 centimeters square. Correct. I think that was Satvika again. 240 centimeters square. Correct, Satvika. And the third one, the number of bricks.
$6,080.
Ma'am, 6080.
6080. That's right, 6080. Let's see the answers in detail. Let's see the working. Have a look at the answer. I'll give you 2 minutes time. All right, so we are given that the dimensions are in the ratio 2:3:4. So let the dimensions be 2x, 3x, and 4x meters. We need to first find the total surface area of the box. We need to first find the TSA of the box. The TSA, as you see, is 52x squared. 52x squared. The TSA of the box is 52x squared. Now, this box can be covered with paper, with two different types of paper. One at the rate of rupees 4 per meter square and the other at the rate of rupees 450 per meter square. The difference, just a minute, children. Yeah. So the TSA of the box is, yeah, we have to be careful here. 2 of LB, L into B, 2x into 3x, 6x squared. 3x into 4x, 12x squared. 2x into 4x, 8x squared. Be careful while calculating here. And when you add all this, it's a 26x squared. 2 into 26x squared, 52x squared. This is the TSA of the box. We have two different types of paper. One which can be covered at the rate of rupees 4 per meter square, the other rupees 450 per meter square. So what will be the total cost if you cover the box using this sheet, which costs rupees 4 per meter square? What will be the total cost? TSA into rate. TSA into rate. Total cost. Rupees 208x square. If you cover the box with the other sheet of paper at the rate of rupees 450 per meter square, then the total cost will be the TSA into the rate. TSA into the rate. Rupees 234x square. Now the difference in the two costs. This is the cost of the paper, which is which costs rupees 4 per meter square, and the other is rupees 450 per meter square. The difference in the two costs is 416. The difference in the two costs is 416. So this one, obviously, this is the rate is more here, so the cost is more here. So this one minus this one, the difference in cost, this cost minus this cost is equal to 416. So on working this, you get the value of x, and once you get x, you can find the dimensions of the box. So this is rupees. Take a screenshot. First, you need to find the TSA and the cost at the two different rates, and then the difference in cost is 416. Frame the equation, find the value of x, and hence find the dimensions. So in 2, we're given that the sum of the length, breadth, and the depth of a cuboid. The sum of the length, breadth, and depth of a cuboid is 19 centimeters. And the length of its diagonal, so the length of the diagonal of the cuboid is 11 centimeters. And we know that the diagonal is given by the formula root of L square plus B square plus H square. Root of L square plus B square plus H square is equal to 11. So we know we are given that L plus B plus H is 19, the sum of the length, breadth, and height. The length of the diagonal is 11 centimeters, which means square root of L square plus B square plus H square is 11. Diagonal is given by this expression, root of L square plus B square plus H square. That is 11. Now we need to find the TSA of the cuboid. That is, we need to find the value of 2 of LB plus BH plus LH. We need to find the TSA, the surface area. If nothing is mentioned, it's a total surface area. So we need to find 2 of LB plus BH plus LH. So now these expressions must be connected. All these 3 expressions, these 2 are given to us, and this is what we need to find. So take up this equation, L plus B plus H is equal to 19. Square this on both the sides. So you get L plus B plus H, the whole square is equal to 19 square. So what is A plus B plus C the whole square? A square plus B square plus C square plus 2AB plus 2BC, or you can directly write 2 of AB plus BC plus AC. A square plus B square plus C square plus 2 of AB plus BC plus AC is equal to 361. 19 square, 361. We know that L plus B plus H is equal to 19. Square root on both the sides. So A plus B plus C the whole square is A square. So L square plus B square plus C square plus 2 of AB plus BC plus AC or CA is equal to 19 square, 361. Now we need to find this. This is TSA. This expression represents the TSA of the cuboid. This expression represents the TSA of the cuboid. Now we need to substitute the value of this expression. This is already a number here. Now we know that root of L square plus B square plus H square is 11. So when you square this one on both the sides, you get L square plus B square plus H square is equal to 121. When you square this on both the sides, you get L square plus B square plus H square is equal to 121. So substitute that. L square plus B square plus H square is 121 plus TSA is equal to 361. So the TSA is equal to 361 minus 121, which is 240 centimeters square. The sum, what are we given? We are given that the sum of the length, breadth, and depth, that is L plus B plus H is equal to 19, is what is given to us. Length of its diagonal is 11 centimeters, which means root of L square plus B square plus H square is 11. And we need to find the TSA, the surface area of the cuboid. So we need to find 2 of LB plus BH plus LH. Take up this equation, square it on both the sides, expand this using the formula A plus B plus C the whole square, which will give you A square, B square, C square, 2 of AB, BC, AC is equal to 361. 19 square is 361. Now this is what we have to find. This is the TSA. So TSA. So we know that root of L square plus B square plus H square is 11. So when you square this on both the sides, we get L square plus B square plus H square is equal to 121. Substitute and hence find the TSA. Find the number of bricks, each measuring 25 centimeters by 12.5 centimeters by 7.5 centimeters. So these are the dimensions of the brick. How many bricks are required to construct a wall? Dimensions of the wall: 6 meters by 5 meters by 0.5 meters. It's given that the cement and sand mixture occupies 1/20th of the volume of the wall. See, like, when we say classroom, boys and girls, classroom, class, boys and girls. So if say 4/9 of the class are boys, then 5/9 of the class are girls. If 4/9 of the class are boys, then 5/9 of the class are girls. And when you add these two, you will get 1. 4/9 plus 5/9, which is 1. If 2/5 of the class are boys, then 3/5 of the class are girls. So here in the wall is made up of bricks and cement and some mixture. This mixture is mixture of sand and cement. Okay, sand and cement. So the wall is made of 2 components. The wall is made up of 2 things. The wall has bricks in it and some mixture in it. It's a mixture of sand and cement. So if the fraction of the mixture is 1/20, then the fraction of the bricks will be 19/20. So 1/20th of the wall is the sand and cement mixture. 9/20th of the wall is the volume of the bricks. 19/20 of the volume of the wall is the volume of the bricks. 1/20 of the volume of the wall is the volume of the mixture, the sand and cement mixture. We'll see that again. Wall, 2 things in it, bricks and some mixture, which is a mixture of sand and cement. Okay, it's given that 1/20 of the volume of the wall. 1/20, you can see here, 1/20 of the volume of the wall is the sand and cement mixture. Cement and sand mixture occupies 1/20 of the volume of the wall. 1/20 of the volume of the wall. So 1/20 of the volume of the wall is the mixture. The sand and cement is occupied by the sand and cement mixture. So the remaining 19/20. 19/20. How do we get that? 1 minus 1/20. 1 minus 1/20. 19/20 of the volume of the wall. 19/20. It's given 1/20 of the volume of the wall is occupied by the sand and cement mixture. So 19/20 of the volume of the wall. Is occupied by all the bricks, is equal to the volume of the bricks. Volume of all the bricks. 19/20 of the volume of the wall is the volume of all the bricks. So let's write that. So volume of bricks is equal to 19/20 of the volume of the wall. This equation is what we, if you understand this equation, then that will take you to the end of the, working. You get the answer. Volume of the bricks. Volume of the bricks meaning volume of all the bricks. Volume of all the bricks. Volume of all the bricks is equal to 9 by 20 of the volume of the wall. Not 9 by 20, sorry, 19 by 20. Volume of all the bricks is equal to 19 by 20. Volume of the wall is the total thing. Volume of the wall is the full thing. 19 by 20, this fraction is occupied by the bricks. The remaining 1 by 20, that fraction is occupied by the sand and cement mixture. So this equation is what you'll have to write. Volume of all the bricks is equal to 19 by 20 of the volume of the wall. Now, how do you find the volume of one brick? L into B into H, because it's a cuboid. It's a cuboid, L into B into H will give you the volume of one brick into, let's say there are n bricks. Let's say there are n bricks. Let the number of bricks in the wall be equal to n. Let the number of bricks in the wall be equal to n. Or we know that volume of one brick is a cuboid. So volume of one brick is L into B into H. But volume of one brick is L into B into H. Volume of all the bricks, one brick LBH, all the bricks into N, where N is the number of bricks. See, like if LBH is if there are 5 bricks, if there are five bricks, this is the volume of one brick. For 5 bricks into 5. For 15 bricks into 15. Volume of one brick into 15 will give you the volume of 15 bricks. So here we don't know how many bricks, we have to find. So let the number of bricks in the wall be n. N into LBH is the volume of all the bricks. LBH is the volume of one brick into n, the number of bricks. Will give us, so this gives us the volume of all the bricks. So we have substituted for this volume of all bricks as n into LBH is equal to 19 by 20 into volume of the wall. Volume of the wall is again a cuboid, LBH. Volume of the wall. There's only one wall. Now don't say n into LBH. There's only one wall. There's only one wall. 1 second, children. Yeah, now, so here it is one wall. So it's not n into LBH. Volume of the wall is equal to LBH. Wall again is a cuboid. Volume of the cuboid LBH. So now substitute. Make sure all the values are in the same unit. Make sure all the values are in the same unit. So like we have centimeter everywhere or meter everywhere. But it's easier to convert to centimeter. So n into, see the dimensions of one brick, 25, L into B, 12.5 into H, 7.5. See, we are substituting N into LBH. LBH is given to us. Take the values is equal to 19 by 20 of the volume of the wall. So here we have 6 meters, so 600 centimeters, all in centimeters into 5 meters, 500 centimeters. 0.5 meters, so into 150 centimeters. We have converted the dimensions of the wall to centimeter. That's it, children. Bring these numbers to the other side. That is, bring these numbers to the other side for division. You can convert 12.5 to 125 by 10. Okay, we will not be comfortable with decimals, the decimal point. So you can just convert that to a fraction like this. You can write 7.5 as 75 by 10. Then take the numbers to the other side and hence find. You can see that this equation has only one unknown n. So take these numbers to the other side and find the value of n. Take a screenshot, children. Yeah. I think we finished this one in the last class, children. Yes, I remember we finished this in the last class. Let's continue. This is your next question. ABCD is a cyclic quadrilateral in which angle DBC, look at the figure for angle DBC. DBC is 80 degrees and angle BAC is 40 degrees. Find angle BCD. Find angle BCD. Children, please write down the question, draw the diagram in your book and try this one. I hope all of you have copied the question and drawn the figure. Tell me, children, what is the measure of angle CBD? What is the measure of angle CBD?
80 degrees.
80 degrees. Angle CBD measures 80 degrees. What is the measure of angle CAD? What is the measure of angle CAD? If CBD is 80 degrees, what is the measure of angle CAD? What do you say about these two angles? Please say something about these two angles, CBD and CAD. What can you say about these two angles, CBD and CAD?
They are equal.
Yeah, they're equal. They're equal, but just explain on that. Sangamitra, did you watch the two recordings? You missed last two classes, right?
Yes, ma'am.
Yeah, did you go through the recordings?
Yes, ma'am.
Okay, good. Yeah, then I think you should understand my question. How do you just say something about these two angles, CBD and CAD?
They're the same chord. They're co-interior angles.
No, they're no. AD and BC are not parallel lines. These are not, even if they are parallel lines, you're not completely right. Only there is no existence of parallel lines here.
They're formed by the same chord or the common chord.
Yeah, they're okay. Which arc makes these two angles? Which arc? Which arc? Angle CBD is subtended by which arc? Angle CBD is subtended by which arc?
CD.
Arc CD, minor arc CD. Minor arc CD subtends CBD. The same arc CD subtends CAD. It's very clear from the way we name the angles. CBD, CAD. See, a CD is the arc. CD is the arc. The angles are made at the points B and A. CBD. Angle CBD is made by the arc CD at the point B on the circumference. Angle CAD is made by the same arc CD at the point A on the circumference. CBD is made by the arc CD, is made by the minor arc CD at this point B on the circumference. The same arc CD subtends angle CAD. Subtends angle CAD at the point A on the circumference. CBD, CAD. The points are B and A on the circumference. The arc is CD. The arc is CD. So they are in the same segment. Both the angles are formed in the major segment. Both the angles are formed in the major segment. See here, CD is the chord. CD is the chord. This is the minor segment. The rest of it is the major segment. And these two angles, CBD here and CAD here, are two angles in the same segment of the circle. So they're equal. This is also 80 degrees. See, this is the major segment. What I've not shaded is the major segment. CBD, I repeat, angle CBD. Don't look at what I'm writing here. Look at this and then see the angle in the figure. Angle CBD is made by the arc CD at the point B on the circumference. The same arc CD makes angle CAD at the point A on the circumference. Point A on the circumference. CBD is equal to CAD because both are subtended by the same arc at 2 points B and A on the circumference. You can see that both the angles are formed in the same segment, the major segment. So they're equal. Okay. So now what is the measure of angle DAB? What is the measure of angle DAB?
120.
DAB is equal to 80 plus 40, 120. 120. What do you say about angles DAB and angle and DCB? What do you say about angle DAB and angle DCB?
And they're supplementary, ma'am.
Why?
As they're cyclic quadrilateral.
Which is name the cyclic quadrilateral here?
And ABCD, ma'am.
ABCD is a cyclic quadrilateral, and what is the property of a cyclic quadrilateral?
And opposite angles of the cyclic quadrilateral are supplementary, ma'am.
Opposite angles are supplementary. So DAB and DCB. DCB is what we have to find. DCB, see, BCD. This one is what we have to find. BCD or DCB. This one. So now that DAB, this one is 120 degrees. This one will be 60 degrees because in a cyclic quadrilateral, opposite angles are supplementary. Please write down, children. You can also write angles in the same segment of a circle are equal. Angles in the same segment are equal. I've just specified angles in the major segment made by the minor arc CD. You can, in general, say angles in the same segment of a circle are equal. So first, we find this angle. This is 80 degrees. So this whole angle is 120 degrees. The opposite angle is 60 degrees. Because ABCD is a cyclic quadrilateral, opposite angles are supplementary. Any questions, children?
No, ma'am. No, ma'am.
All right. Have you finished writing?
Yes, ma'am.
1 minute,
Yes, ma'am.
ma'am.
Should I wait, Nivedita?
Yes, ma'am. 1 minute.
Yeah.
Yes, ma'am. Thank you, ma'am.
Yeah. This is your next question. Please write the question. Draw the figure. Yeah, what's the measure of angle PRB? Find angle PRB. PRB.
35 degrees.
35 degrees. Why?
They are subtended by the same arc.
Same arc. Which is the same arc? Which is that arc?
Arc BP.
PB. Arc PB subtends arc PB. This is a minor arc. This arc PB. The minor arc PB subtends PAB on the circumference at A. Sorry. This arc PB makes angle PAB at the point A on the remaining part of the circle. The same arc PB subtends angle PRB. See here, same arc, PRB. You can make out from the way we name the angles. Angle PAB, I've mentioned this many times in the earlier classes. PAB, PRB. Angle PAB, angle PRB, made by the same arc PB at the points A and R on the circumference. So there are angles in the same segment of the circle. How are they in the same segment? See, if you connect the points P and B, I'm telling a straight line. If you connect the points P and B, it's a straight line, children. Okay, so this becomes the minor segment. This becomes the minor segment. The rest of it is the major segment. So you can see that the points A and R are on the circumference of the major segment. The points A and R at which the angles are made are points on the circumference of the major segment. I've shaded the minor segment. See, with respect to the chord, you can make out the two segments. With respect to the chord PB, there are two segments, the major and the minor segment. When you connect the points P and B, so that is a chord PB. This is the major segment, region bounded by a chord and an arc. Region of the circle bounded by a chord and an arc is a segment. So this one is the minor segment, and the rest of the circle is the major segment. See a circle, minor segment. The rest of it, this is the major segment. This one is the major segment. So angle PAB and PRB are two angles in the major segment of the circle. They are made by the same arc PB. So since angle PAB is 35 degrees, PRB is also 35 degrees. So this is 35. What's the measure of angle PBR? PBR. PBR, children? Think. Please think about PBR and BPR. I'll just get back, children. Yeah, children, PBR.
Is it 115 degrees? No?
Yeah, explain.
Ma'am, angle B, angle BPQ plus angle PQB is equal to angle PBR.
Angle BPQ plus
Angle PQB is equal to angle PBR.
okay. Yeah, next. What is the measure of angle? You said BPQ.
BPQ is equal to 90 degrees. Angle in a semicircle.
BPQ is not an angle in a semicircle. BPQ. It's out of the circle. BPQ is not an angle in a semicircle. All right.
BP, ma'am. Sorry, ma'am. BP.
Name the angle in the semicircle.
Ma'am.
Okay. So children, now you see that AB is a chord passing through the center of the circle. AB is a chord passing through the center of the circle. O always, even if it is not mentioned, O always represents the center of the circle. O represents the center of the circle. You can see that the chord AB passes through the center O, which means AB is the diameter. Or we know that angle in a semicircle is a right angle. Circle, diameter. If you take any point on the semicircle, supposing the diameter, say AB, the point P, join the ends of the diameter to P. Join the ends of the diameter to P. So this makes angle in a semicircle. This is 90 degrees. Let me show you again. Circle, circle, diameter on the semicircle. There are two pieces, right? Two semicircles here. One above the diameter, one below the diameter. Take a point on the semicircle. Take a point on the semicircle. Join the ends of the diameter to that point. Bring the ends of the diameter to that point. Now this is the angle in a semicircle. This is the angle in a semicircle, which is a right angle. See it? Semicircle, semicircle, semicircle. Take a point on the semicircle. Bring the ends of the diameter to that point on the semicircle. This one, angle in a semicircle is a right angle. This is 90 degrees. So you can apply that here. AB is the diameter. AB is the diameter because it passes through O. P is a point on the semicircle because this is the semicircle. Diameter divides the circle into the circle into two pieces. Circle meaning, okay, circular region into two regions. The diameter divides the circular region into two halves. Each half is a semicircular region. When I say circle, I'm saying this one, this circle. This is the circle. This one is a circular region. Diameter divides a circular region into two halves. Each one is called a semicircular region. Diameter divides the circle. When we say circle, we're talking about this piece. Diameter divides a circle into two halves. Each half is called the semicircle. Each arc is called the semicircle. You can see the diameter here. This is the diameter because it's a chord passing through the center. This is the semicircle, and this is the other one. This is the other one below the chord. This is the other one. All right. So now on the semicircle, we have this point P. And see here, bring the ends of the diameter. Bring the ends of the diameter to that point P. See here, AP, BP. This angle is a right angle. This angle. This one is 90 degrees. So if this is 90 degrees, linear paraxium, this also will be 90 degrees. This is also 90. So angle APB is equal to 90 degrees. APB is equal to, I'll repeat. Okay, let's finish it once and I'll repeat it. APB is equal to 90. Angle in a semicircle is a right angle. Therefore, angle BPQ is 90 degrees, linear pair. Now, by using the exterior angle property in a triangle, angle PBR, this angle P, sorry, when beyond the angle. Angle PBR, see here, PBR, this angle. So this is the triangle. This is the triangle. PBQ is a triangle. PBQ is a triangle. This is the side QB which is produced, and the exterior angle is formed. This angle is equal to the sum of the two interior opposite angles. The interior angle, the two interior opposite angles, 90 plus 25. So angle PBR is equal to 90 plus 25, 115 degrees. 115 degrees. Next, we have to find angle BPR. BPR. Sorry. That you can tell me. Let me repeat this. Let me repeat angle PBR. AB is the diameter. P is the point on the semicircle. Join the ends. Bring the ends of the diameter to the point P. In other words, join AP, join BP. AP, you can already see the line segment AP, but BP we don't see. So we join BP. Now this is angle in a semicircle, which is the right angle. So that is the first part. Now if this is 90, the adjacent angle, this is also 90, linear paraxylon. Now the triangle is triangle PBQ. PBQ is a triangle. In triangle PBQ, the side QB has been extended, has been produced. So exterior angle PBR is formed. Exterior angle PBR is formed. This exterior angle will be equal to the sum of the two interior. Don't take this. Interior opposite angles. This one plus this one. Which makes it 115 degrees. Yes, children. That's about yeah, next we need to find angle BPR. Did you understand the second subdivision, children? Do we understand how to identify angle in a semicircle?
Yes, ma'am.
Yes, Shreyas?
Yes, ma'am.
Okay. Children, now we need to find angle BPR. 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 Okay. BPR, this one, this angle. So we found this one, right? PBR. This is what we found. This one is 115 degrees. Okay. And we have already found this angle, children. How much is this equal to? PRB. We already found this. How much is this?
35, ma'am.
35. This is 35. So CF, this is 35. PRB, this is 35. This is 115.
BPR is 30, ma'am.
30. How? By using
Angle sum property, ma'am.
angle sum property in a triangle. So in triangle BPR, this angle is one angle is 35 degrees. The second angle is 115 degrees. So the third angle can be found using the angle sum property. Take a screenshot. We have one more. We'll wind up the class with that one. Just one more. Done, children? Took a screenshot? Please complete this in your classwork. Okay, let's see the next one. Find the values of x and y. Find the values of x and y. Yes, children? Okay, we need to use the property What property? ABCD is a quadrilateral. What kind of quadrilateral is it? It is a
Cyclic quadrilateral.
cyclic quadrilateral. What is the property we know about the opposite angles in a cyclic quadrilateral?
Opposite angles are supplementary.
They are supplementary.
Opposite angles are supplementary. So angle A plus angle C is equal to 180. Angle A plus angle C is equal to 180. What is angle A? What's angle A? 2x plus 4 degrees. It's 2x plus 4 degrees. What's angle C?
2y minus 4.
So 2x plus 4 plus 2y minus 4 is equal to 180. This is one equation. So you get 2x plus 2y, because plus 4 minus 4 gets cancelled, is equal to 180. Or dividing by 2 throughout, you get x plus y is equal to 90. Dividing this equation by 2 throughout, you get 2x by 2. 2x by 2 is x, 2y by 2 is y, and 180 by 2 is 90. Dividing the equation, divide every term in the equation by 2. So that will give you x plus y is equal to 90. So this is one equation. So similarly, we have angle A plus C is 180. Likewise, what's the other equation we can write? Angle yes, children. A plus C is 180. What is the other one?
Angle B plus angle D is equal to 180.
Angle B plus angle D is equal to 180. So angle B is x plus 10. Angle D is 5y plus 5 is equal to 180. So x plus 5y, 10 plus 5 is 15, is equal to 180 minus 15. So we have x plus 5y is equal to 165. So these are the two equations. I mean, like in polynomials, we solve the equations and find the values of x and y. Similarly, solve these two equations and find the values of x and y. Take a screenshot, children. Please complete these two answers in your book.
Yes, ma'am.
Please complete your classwork and then share the pictures. You can share it by tomorrow. Please complete the classwork.
Okay.
The three questions on volumes and surface areas, if you had not got the right answers, and whatever we did in circles, complete these in your classwork and then share the pictures. Class, use the emoji, raise your hand. Hitesh and Deepika, are you there?
Yes, ma'am.
Deepika?
Yes, ma'am, I have raised.
Okay, oh, I can't see. Okay. All right, Deepika. So Deepika, Hitesh, Sangamitra, Satvika, Vasudevan, Tarun, Shreyas, Pratiksha, Deepika, Nivedita, Ananya, and Ara. All right, children. So that's it for today's session. Thank you so much. If you have any doubts, please stay back and get it clarified. Else you may leave the meeting. Thank you.
Thank you, ma'am.
Ma'am.
Good night.
Thank you.
Good night,
Thank you,
children.
ma'am.
Good night, children.